Hello, so we have quantitative circuit proportional reasoning number 5. And what we have here is a circuit has current of 3A and another one has half the resistance and then twice the voltage. And so what we're looking for is the current of the new circuit. So our unknown here is going to be the current of the new circuit. And we're going to go ahead and write the current down in our table of 3A. And we're seeing that it is half the resistance, so the coefficient of resistance is 1/2. And we have twice the voltage, so the coefficient for voltage is 2. And next what we're going to do here is just kind of think about how this is all going to make sense for us. And since we're looking for the current value, I'm just going to go ahead and highlight it here in blue and fill in our blanks. So we have the coefficient 2 for voltage, and then we have 1/2 for resistance. And so we're going to think about 2 is equal to something times 1/2. So let me write that down here. 2 is equal to question mark times 1/2. And we have 2 is equal to 4 times 1/2. So essentially what you do is 4 times 1 over 2 is going to give us 2, right? So then the coefficient for the current is going to be 4. And so we have 3A times 4 is going to give us 12 amps. And we don't really need to know the values of the other things because it doesn't really matter to us right now. It's just asking for what is the current of the new circuit. And so we're going to take a look at this part right here where it's just the current. And so we'll write down the coefficient of 4 and the variable I. And we'll keep the coefficient 4 and multiply it by the original value of 3 amps. And it gives us the answer of 12 amps. Okay, so now for the written description part. So half the resistance and twice the voltage means quadruple, so that means 4 times as much, the current. And so that's pretty much it. When we increase, or let me write this down right here. So V is equal to I times R. And so when the resistance is decreased, so half the resistance, that means that the current is going to increase, right? Because it's not being limited so much. And when we increase the voltage, then that means that the current is going to increase because they're directly related.